and I'm getting negative. I'm going to store that guy in V just for fun. We're almost done with the suvat part. We can do, if you look horizontally, we've now got the time and the velocity. We can use this formula, can't we? And the reason we're not doing 1/f at squared on that is that a is 0, correct? I mean, I really am doing 1/f at squared. I'm just too lazy to write it up there because it's 0, right? So on this side, I'm going to say s equals 5 times 1.124. Is the final vertical velocity, yes. Oh, 26, is that what you get? Wait, where? This? No, it's actually 11.029 if you don't round, but let's not worry about it. Okay, so this is 5 times alpha t. 5.621. Here, I'm going to just say make it a 3. Is that okay? Are we good so far? I did this times this. Yeah? Yeah? So notice that you can do math. I can't use the 5 with the 11. I can't use, right? These guys don't mix. The only thing that they share is time. Otherwise, they're separate, yes? They don't affect each other. Okay? Now we're ready. Now we've done this, right? And typically the way this plays out is that you can do this side and then t goes across, or in this case you can do this side, t goes across, you can finish the other side. Okay? Yeah? Now we have to answer the questions that were asked, and sometimes we have to do vectors here, right? So the first question was, how far out did we land? And the answer to that with 2 sig figs is 5.6 meters, which I think is something like 18 feet or something out into the yard. It seemed like we were halfway across that yard, but not quite, right? Maybe by the time our faces hit the ground, we were, right? You know? Okay. We hit the ground in about 1.1 seconds with sig figs, and then our velocity of impact in vector component notation is deadly simple. Here it is. Okay? 5 meters per second in the x direction plus negative 11.03 meters per second in the y direction. Do you see that vector component notation is the native language that we're going to be using? We do our math as vector components, right? So it's this in the x direction, this in the y. Yes? Those are the components of the velocity. I was moving down faster than I was moving over, wasn't I? Yeah. Now let's draw a picture of that velocity. Okay? A picture of that velocity looks like this. Over 5, down 11.03, right? So I draw the 11.03 smaller than or bigger than the 5.0, right? Now find the magnitude. 5 squared plus 11.03 squared, right? And then find this angle. That's going to be inverse tan of 11.03. Calculate that. There's nothing else to do. Syntax there. Okay, just go to it. Yeah, 65.6. Right, and then what our magnitude is 5 squared plus 11.0. Actually, I'm going to use my unrounded value, so I'm going to go alpha v squared. You guys get like 12.1? Okay, so if somebody says, what's the velocity of impact, and they don't tell you what form to give it in, vector components are the easiest way. 5.0 in the x, 11.3 negative in the y, meters per second. If they say angle magnitude, you would draw this picture for them. You'd say, well, it's at an angle of 65.6 degrees with the horizontal, downward, and the magnitude is 12.1 meters per second. Now, if somebody says, what's the speed of impact, What number do you give them? Do you give them 5, 11.303, or 12.1? Which one is the speed? The 12.1 is. Yeah, this guy's the speed. That's the speed. The speed is the magnitude. The magnitude of velocity is speed. Yes? Okay? So if they say speed of impact, you can just say 12.1. It wouldn't hurt to give the angle, but that makes it a velocity, right? That's the only difference between them. Are you guys ready for the varsity question? Okay. No, this is just pretty mundane, right? Now, what? The magnitude of the velocity. Not the final in the vertical, not the final in the horizontal, but the magnitude of it. The hypotenuse of the velocity is the speed. Yeah. Yeah. What? Yes. Yeah. All right. Here's the varsity question. Okay? By varsity questions, I mean this. I'll pick some other parameter. Okay? So in this case, I want to pick the parameter of, not when we hit the ground, but, and I don't know why you'd want to know this, but just because you can, right? Okay? Okay? Let's suppose that we've got a plane here. We went out 5.6 meters. Let's suppose that we go out 4 meters from the edge, right? 4.0 meters. Imagine a plane, an imaginary plane like that, right? At 4.0 meters horizontally, where am I? In other words, how far down have I gone? How far over was 4 meters? How far down have I gone? And what is my velocity? Everything about my velocity in vector component and angle magnitude. Okay? So I'll say how far over? I'll say maybe how far above the ground or how far down. Or I might give you a time, which is actually one of the easiest ones. And I want you to tell me everything about it. Where is it? What's its velocity? Right? Now don't ask why would I care, because you care, of course, don't you? Yeah, of course you care. Right? You care deeply. The 4 meters is, we're saying, when you pass a plane that is 4 meters from the edge of the cliff edge, right? How far down are you? What's your velocity? Right? Just, I don't know why you'd want to know that, but let's do it. Okay, so. All right, who knows something for the varsity question? Yeah, we're going to have varsity questions. On the test, on the homework. Chung's got something. Yeah, horizontal displacement will be 4 when this problem's over, right? Noah's got something. Yeah, horizontal acceleration is 0. I did not recently eat at Taco Bell. All right. There we go. Yeah, these are always true, right? This is the acceleration vector of Earth. Ta-ta-ta, yeah. This is always true. Yeah? It's always true, by the way, that these guys will be equal to each other. John's got something. Or he's scratching his head. No, go for it. Tell us something else. What's our initial vertical velocity? It's 0, right? Yeah, there we go. 0 meters per second. Right? Now, let's see. And then we've got, Paul knows something. Oh, you're going to do vertical. What about horizontally? We still know something, right? Yeah, that's our velocity initial and our final, right? Yeah? And that's all we know. Now, sports fans, Caleb, don't do that. Now, if you look at this, this is going to play out differently. In the previous one, we solved the vertical side, and we slid the time over and then solved horizontal. This one, we're going to solve probably horizontal, right? The reason being that we don't know anything else vertically, correct? Okay? So S equals ut, there is only one formula. You never have to sit there on the horizontal side and say, gee, I wonder what formula I'll use today. It's always that one, right? So isn't our time 4/5 of a second? Yeah, there we go. So in case you didn't follow that, t then is just s over u, isn't it? So that's 4 divided by 5, and that's 0.8 seconds, right? And then we can castle that guy across, only do that once, right? Now we're set. Don't we know three things vertically?